Alright, so we're going to start off with, basically this is some review stuff. We really got to be fluent with our properties of exponents here. And so I listed some of them here. I got when you multiply with common bases, remember you add the exponents, or if you divide, you subtract. I got exponent to the power of another exponent. Remember, that's just like multiplying exponent. That's going to be important. We're going to use that one a lot here. So you got to be able to go back and forth between these two forms. And then also remember the negative exponent gives us the reciprocal, or it divides. So you got some explanations here. Read over these. You need to be familiar with all these rules in order to do these skills. Basically, when you're doing these types of problems, this is the key. Okay, to make these problems easy, what you want to do is you want to play with the original expression. So here's the original expression, and answer choices if they have them. Here's some answer choices to see how you might be able to change the way they look, and then see if any of them are equivalent. So let's play with the original problem here on example 1. Okay, I see a few things going on here. The first thing I see is that these things have the same base. So I'm right away I'm thinking about what I can do with that. And if they have the same base, right away that tells me I can do this. I can add the exponent. So I can write this as 3 to the 9m squared plus 9m. Okay, and I'm going to see if that's here anywhere. And sure enough, it's right there. Boom. Okay. Is there any way that I could write this 3 as a base of 9 to get here? Well, in order to do that, I have to have a squared, right? So is there a 2 that I can factor out of here? No, there isn't. So I can rule this one out. So again, let me just kind of explain what I was doing there. I was saying, okay, how do I get a 3 base to match a 9 base? Well, the only way to get a 3 base is if I can somehow get this to be, well, we could play with this one so you could see. Couldn't I make this 3 squared to the 3m squared plus 3m? And if I did that, this 2 here now, this exponent to an exponent, I can multiply that. And so this would actually end up being 3. If I multiply that or distribute that 2 across, this would be 6m squared plus 6m. And that's definitely different than what we have here. So that's why A doesn't work, okay? You can see that they're not going to match. Okay, this is 3 to the 18m squared. Well, I already have a single 3, but is there any way I could just get this to equal 18m squared? I mean, I could factor out a 9, if we think about it here. Just give myself some space. I could factor out a 9 and an m, right? And then I'd still be left with an m plus 1, but there's no way to get to an 18 up here and to get rid of this 1. So we're pretty confident then that this isn't going to work either. So we found the only one that works. That's not only the case. Sometimes there's multiple ones that'll be equivalent on this skill here. So just want to show you how we do that. Remember, it's important to use your properties of exponents. Okay. On this one, I'm going to get you started on this one, on practice 1. Here's what I want you to recognize. You got to see here that this is subtracting in the exponent. And remember that this is like saying 81t squared divided by 81 to the 0.5t, or the 1/2 t. That's what subtracting exponents is like. So think of it like that, and then I think you'll have an easier time manipulating these to see which ones are equal. I'll also tell you this: 2 out of these 3 are the same. So keep working until you're very confident that you have 2 out of these 3 that are the same. Go ahead and give it a try, and then pause the video when you're ready to check your work. Okay, so hopefully right away from here you should have seen what can you do with that 1/2. Okay, so I kind of wrote it like this so we could see it a little bit better. Remember that a 1/2 is the same thing as saying the square root of that number. Well, the square root of 81 is 9. So this is like saying 81t squared over 9 to the power of t then. And we could get rid of that 1/2. Well, that's right there. So A is an equivalent form. Okay, on part B here, I was trying to see how I can mess with this, and I noticed that I have a t squared on top and a 0.5t on bottom here. Well, 81 could be written as 27 times 3. That's equal to 81. And then if I wrote it as 27 times 3, I could split it as, since they both have the same exponent, I could write it like this. So that part's true. And on the bottom, 81 can also be written as 9 times 9. And so then since they have the same exponent, I can split them up and write it like this. And so, yeah, this part is true as well, so I know this one is true. For this one, it didn't look like it matched, so I went ahead and saw that these have the same exponent, so I wrote it as the same exponent, and then I thought, well, 27 divided by 3 is 9, so this is really equal to 9t squared minus 0.5t. Well, they have the same exponents, but 81 and 9 definitely don't match, so we now know for certain that this one does not work, so I cross it all off. So again, there's no like just short, quick way to do this. It's a matter of playing with each of these and making sure that they're not equivalent. Get them all in the same form, get them looking like each other, and you'll be able to tell whether they're equivalent or not. But you're going to have a little perseverance here, because you're going to have to be thinking about it, manipulating each expression to see how you can kind of play with it, see how you can get it to work. Similar strategy here on example 2. It says find the value of a that makes the following equation true for all values of x. So let's take a look at this. Basically what we're trying to do here is we're trying to figure out what a is. And in order to do that, we're going to need to kind of manipulate either side of the equation so that it matches. And the first thing that I see here is that they both have an x in the exponent, and that's good. Because that means on the right, I could write this as a to the negative 7 to the x. And this is still 1/9 to the x. And this is really helpful because now I can see if these are both being raised to the same exponent, well, I could get rid of them essentially because it's on the same side of the equation. I mean, you could kind of imagine taking the x root of each of these, but the idea is if they both have the same exponent, then these things must be the same. So we could kind of just think of this now as 1/9 equals a to the negative 7th. And so now, what could we do? Well, what could we plug in for a so that this would always equal 1/9, right? Another way of thinking about this is what could a be with an exponent so that we can neutralize this negative 7. What I mean by neutralize is maybe just somehow just make it a 1. And so, well, we can make this a 1 if a was really, if it had a negative 1/7 exponent. So imagine here is your a, and I'm going to just kind of fill in the parentheses here so that my a would go right in here, and so that when I raise it to the negative 7 power, these things would just kind of become 1, if you think about that. And so then what would I need to plug in here so that it would definitely equal 1/9? Well, that would just be 1/9, right? So 1/9 the negative 7 to the negative 7, well, that's just like a 1, and so now it just becomes 1/9. So we can see this would be my a. And we could rewrite this a few different ways now. We could think of this a as 1/9 to the negative 7. Well, that's the same thing as 9 to the negative 1/7. And so that would be a reasonable answer. That would be a reasonable answer for a. You might also see it in the form of, how about 1 over the 7th root of 9. That's another way that you might say what a equals. But just kind of manipulated it so that we can get the a to kick out exactly what we want on this side. So I know it's a little bit tricky to think about. It's a little bit of playing with it. It just takes some thinking, and you can get through it. Again, I'm going to help you guys with practice number 2 here so we can kind of see the pattern of what's going on. Again, the first thing I notice is that I could write this so that we have an x in the exponent. And I think if you just do that, this one would be a lot simpler. See, this one had a negative 7 with the a, but this one doesn't. So I think this one's quite a bit easier. Think about writing this whole expression so that you just have an x in the exponent. Give that a shot, and then I'll check back in just a little bit. Okay, so if you would just rewrite it, bring the 5 or the negative 5 inside these parentheses. This is still true because remember that an exponent to an exponent It's just like multiplying exponents. So I haven't changed its value, just changed the way it looks, and the a to the x, the a is already kind of by itself except for this x variable. So now we can see that if these two exponents are the same, then these two bases must be the same. So a must equal whatever's left inside here. That's why I boxed it. And 1/4 to the negative 5, that's the same thing as saying 4 to the 5th, and 4 to the 5th is 1024. So all three of these actually would technically be correct. You know, maybe it's best to just simplify it, but just want to show you that all three of those are correct. So I know it's a little bit tricky. If it's get confusing, you might want to rewatch this. There's also some helpful videos on Khan on this topic, but it's just about kind of manipulating either these equations or these expressions based on your rules of exponents. So you're changing the way it looks to see how you can get things to match up how you want them to match up. The more you do this, the easier it'll become, but it does take a little bit of just practice and kind of just messing with it before you get real comfortable. All right, see you guys on the next video.